Hello again. Today we're going to have a very brief review of how you subtract integers. But first, what is red and white and black all over? And the answer that you have to this sort of tells your age. Like when I grew up, it was a newspaper. And now it's getting harder and harder to even find newspapers with internets and blogs and feeds from the internet. But what else could it be? Black and white and red all over. It's a skunk with diaper rash. It's an embarrassed zebra. If you think of something else that's red and white and black all over, go ahead and send me an email or respond to YouTube and I'll add it to my collection of very lame jokes. Okay, subtracting integers. The key that you're going to want to remember when you are subtracting is that subtraction is the same thing as adding the opposite. So, let's say if you have two numbers, A and B, and as you know, algebra, when we're studying algebra, we're adding the idea of solving for an unknown amount, an unknown quantity, and that's when we use letters or variables to represent what we're trying to find. So here this says you've got one number that's A, we don't know what it is, but we're going to call it A, and we have a number that's B. Don't know what it is, we're calling it B. We want to subtract those two numbers. And subtraction is the same as adding the opposite. So if you have A minus B, that's the same as saying A plus the opposite of B. And you think, oh, I'm just sort of shaking here because I don't like all of this abstract talking. Well, let's plug in a couple of numbers right here. 4 minus 2. That's this. Now, you know 4 minus 2 is 2. But that's the same as saying 4 plus the opposite of 2. The opposite of 2 is a negative 2. And you remember from seeing things on the number line where we used illustrations of how you can add and subtract numbers on the number line. It's a tedious process that you certainly don't want to use as a matter of course, but it illustrates something, gives you a picture. And since some of us are very visual learners, it helps us sometimes to understand. This here, we have a positive 4, so we start at 0 and go 1, 2, 3, 4 units to 4. Now we're going to add from our 4 a negative 2, which tells us that we're going to move 2 units to the left, or 2 units in a negative direction, which puts us at a 2. So whether you say 4 minus 2 is 2, or 4 plus a negative 2 is 2, you've arrived at the same value. And key to being able to do subtraction like this is remembering what the opposite of a number is. So let me erase this and remind you using our number line what the opposite of a number is. If we have 0 and we have 4 and we have a negative 4, the opposite of a number is the number that is the same distance from 0 in the opposite direction. So the opposite of 4, how many units is 4 from 0? Well, it's 4 units. It's a positive 4, so the opposite of 4 is whatever number you have that's the same distance from 0 in the opposite direction. So the opposite of a positive 4 is a negative 4. That sort of makes sense. We can think 4 and negative 4 being opposite. Well, it changes. Doesn't really change, but let's think of it in a way that you might not have thought of, because a lot of people adults and kids together think if something is opposite, it's negative. But those don't mean the same thing. Because what is the opposite of a negative 4? Well, remember, the opposite of a number is what is the same distance from 0 in the opposite direction. So if we're starting with a negative 4, we've gone 4 units to the left of 0 on the number line. Well, the same distance from 0 in the opposite direction would give us a positive 4. So the opposite of a positive 4 is a negative 4. The opposite of negative 4 is a positive 4. And you'll find that this minus sign here is pronounced several different ways. You can say that's a minus 4, it's a negative 4, or it's the opposite of 4. Minus 4, negative 4, opposite of 4. These are 3 different ways that you can articulate this expression right here. The minus symbol with a 4, you can read it minus 4, negative 4, or the opposite of 4. And depending on what you're doing, sometimes it makes more sense to use minus, sometimes it makes more sense to use opposite. So this is what we're going to be working with when we're subtracting integers. To subtract an integer, you want to be able to add the opposite. So let's see an example. If we have a positive 4 and we want to subtract a negative 4, a negative 2. Let's remember, what are we going to do when we subtract a number? We add. When we're subtracting integers, we're going to add the opposite. In other words, you're really only going to think about this when you're working with negative numbers, with signed numbers. So here this says subtract a negative 2. What's the opposite of negative 2? Negative 2 is on the left of the number line. Positive 2 is on the right of the number line. So we have a positive 4, and we're going to add its opposite. So our solution is a 6. 4 minus a negative 2 is a positive 2. What we do here is add the opposite. We change from subtracting the number to adding its opposite. Okay, let's look at another number. Let's do negative 3 minus a negative 2. So we have negative 3 minus a negative 2. Okay? Subtraction is the same as adding the opposite. So we're going to change the subtraction problem into an addition problem. And the way that you do that is we're going to add the opposite of this number that's right here in parentheses. The opposite of a negative 2 is a positive 2. Now, this tells us what are we going to do when we're adding integers? Well, we have opposite signs here, don't we? What do we do when we have opposite signs? You just think that you're subtracting the smaller number from the larger number, and you're using the sign of the number that you think of as being larger. The technical definitions involve absolute value. You can look back to section 1.3 in Bob Jones University Press Algebra 1 if you want to get a review of what Algebra 1 is. So we have a negative 3 minus a negative 2. We add the opposite of 2, which means we have negative 3 plus 2. Subtract the smaller number from the larger number, gives us 1, and we're keeping the sign of the number that has the larger absolute value, which is where we get that -1. Okay? Now, let's see if we have how about if we have -3 minus 2? What are we going to do here? -3 minus 2. What are we subtracting? We're subtracting 2. Subtraction is the same as adding the opposite. What's the opposite of 2? It's a -2. When you add signed numbers that have the same sign, you add the value, their absolute values together. 3 plus 2 is 5, and you keep their sign. It's a -5. Let's take a quick glance at this on the number line, just to verify what we're doing. -1, -2, 3, -4, -5. We have a -3. Start at 0, move 3 units. To the left takes us to a -3. This says subtract 2. Go 2 units further to the left. 1, 2. And look at that, we have the -5. So subtraction is the same as adding the opposite. Let's say if we have -15 minus 7. -15 minus 7. Let's change this to an addition problem. -15. We want to add the opposite of a -7. The opposite of 7 is a -7. Our signs are the same, so we add the numbers, add their absolute values, and keep the sign that's being used. It's going to take you just a little bit of practice to be comfortable with these or to remember exactly how they work, but I know that you'll be able to do a great job with them. Just keep at it, it'll make sense. And thank you for listening today.